for solving polynomials unit 10. We're going to solve by factoring for all of these. So we'll start with number 2, 4x squared minus 36x. This is a binomial, but I should notice when I go to factor that I always have to look for a GCF first. Here it looks like the GCF, they both have an x and they both have a 4. So I'm going to pull 4 out of both. I write the GCF in front. When I divide, I'm left with x minus 9. Here, that's actually as factors that I can get. So I'm going to set each factor equal to 0 and solve for x. Divide by 4. Here I have one root at 0. And then when I add 9, I get a root at positive 9. This was a quadratic, so I should have 2 roots. And that's it. That's the first one. Number 4 is also a quadratic. I'm going to solve this by trying to split the middle. It's a trinomial. 3 times 1 is 3. I need two numbers that multiply to 3 and add to negative 7. Ooh, doesn't it look like it's going to work? So it's prime. It doesn't factor, so I have to use the quadratic formula. For the quadratic formula, I take the opposite of b plus or minus the square root of your b in parentheses squared minus 4ac all over 2a. Now I'm going to take Desmos, and I'm going to simplify the radicand, what's under the radical here. So what I have is negative 7 squared minus 4 times a times c. And I get 37. 37 is not a perfect square, and it's actually prime. It doesn't have another perfect square that goes into it. So that's your answer. Those are your 2 roots right there. They're kind of yucky, they're irrational, but that's it. It's a little simpler than you think. All right, those were all quadratic, 1 through 4. Now let's look at cubic and quartic. All right, these are a little higher order. Number 5 is x cubed plus 64. It's a binomial. They're both perfect cubes. This is the one where you have a short set, 2 term by parentheses, and then 3. So you start by taking the cubed root of x cubed, which is x. You take the cubed root of 64, which is 4, and you use those to fill in all the rest of the blanks. The first blank in the trinomial, you square the x. The last blank in the trinomial, you square the 4. The middle term, you multiply them together. All right, now I fill in all my signs. I start with the same sign, which is plus, opposite, always positive. Now to solve this, the first term, x plus 4, that's really easy to solve. I set it equal to 0, I subtract 4, and I see that my solution is at negative 4. That's the one real root. The other guy, I have to use the quadratic formula. So I'm going to take x equals, I take the opposite of b, plus or minus. I now do my b squared minus 4 times 1 times 16. And now we use Desmos to help us. So I have negative 4. Oh, I should have just left that. Let's do this. Negative 4 squared minus 4 times, let's see, 1 times 16. I get negative 48. Over 2. Now, radical 48. Here's a perfect square. 16 goes into that. It's radical 16 and radical 3, which is 4 radical 3. So when I simplify this, I get x equals 4 plus or minus. Now it's a negative, so I'll have an I. 4i radical 3 over 2. If you leave your answer like that, it's fine. But notice that 4, 4, and 2 are all divisible by 2. So I can divide those by 2 and get 2 plus or minus 2i radical 3 over 1, but I don't have to write the over 1 if I don't want to. Those are equivalent statements, so you can write either one. All right, number 7, flip your paper over. 2 terms, let's look for a GCF. Looks like I have an x squared in both. So if I pull out an x squared, I'm going to be left with x minus 3. Now here, I'm going to just go ahead and take both factors equal to 0. This is a cubic, so I'll get 3 terms. When I square root x and square root 0, I get plus or minus 0, which really just means I have 0 twice, right? Positive and negative 0 are the same. So that means I have a multiplicity of 2 at that root. So 0 and 0. And then I add 3 and get x equals 3 is the other root. And that'll be it. All right, let's see. We have 2 more to do, 9 and 11. Number 9, there's no GCF, but they're all perfect squares, actually. I can use the difference of squares here. So I'm going to take the square root of both. The square root of 81x to the 4th is 9x squared. The square root of 16 is 4. Put a plus in 1, a minus in 1. Since those are both binomials, and they have an x squared, I can actually set them equal to 0 from here if I want to, and solve for x. Now the left one, I'm going to add 4 to both sides, and divide by 9. Now 4 over 9 is not the nicest fraction, but it'll actually work out okay. I take the square root, and when I take the square root of a fraction, remember that just breaks the radical up over the fraction. I still have a plus or minus, and the square root of 4 is 2, square root of 9 is 3. Plus or minus 2/3. That's 2 of your 4 answers. Now the other guy, same kind of thing. I'll start by subtracting 4. We're going to have a very similar answer here with one difference. I have a negative when I take my square root, which means that my answer is going to have an I. Okay, so let me do this. I'll have the square root of negative 4 over the square root of 9. Square root of negative 4 is 2i, and the square root of 9 is 3. Plus or minus in front. Those are all 4 solutions. All right, last one, number 11. 4 terms, so I'm going to go ahead and factor by grouping. The GCF of the first group is x cubed times x plus 7. The next one is negative 8, x plus 7. So it looks like here, my factors are x cubed minus 8 and x plus 7. Now, I'm not done. I have to keep factoring the left using my method of SOAP. Right? Short set of parentheses, long set of parentheses. X plus 7 on the end. All right, the cubed root of x cubed is x. Cubed root of 8 is 2. I fill in the first blank by squaring x. I fill in the last blank by squaring 2. And multiply them together to get the middle blank. My signs here start from the negative. So my signs are same, opposite, always positive. All right, I know we've done a lot of cubes, but that's the hard one. I want to make sure you know it. The first 2 factors, we're going to have 4 total answers, come from the guys on the end. So those are easy. X minus 2 equals 0. When I add 2, I get a root at 2, an x-intercept. And then over here, when I subtract, I get an x-intercept and negative 7. It's just the inside part where I have to use the quadratic formula. Take the opposite of b, plus or minus the square root of 2 squared, minus 4 times 1 times 2. Sorry, it's squeezed in there. All over 2. All right, take decimals, find that answer. So opposite of, let's see, positive 2 minus 4 times 1 times 4, which is negative 12. Oh, I wrote that wrong. I messed up. I'm so sorry. 2 squared. This last blank of SOAP should be a 4. I'm so sorry. That should be a 4. So this will be a 4 in the parentheses here, which gives me negative 12 down here. Sorry about that. Sorry, you don't have a class behind you to tell you made a mistake. Radical 12 here will become we'll have an I, but radical 4 times radical 3, which is 2I radical 3. So I have negative 2 plus or minus 2I radical 3 over 2. You can leave that as your answer. That'll be the other 2. Or you can simplify all the 2's. Divide them by 2 to get 1. So you have negative 1 plus or minus 1I radical 3 all over 1, which would be your answer. So either one of those boxes there at the end would be correct. All right. Just have your test review left, and then you're all set. If you have other questions, ask your teacher for help.